This video is going to cover problem number three of chapter 18 for Principles of Microeconomics, Greg Mankiw's book. And so if you would first give it a shot and then check your answers as I go through it and explain it, that would probably be the most beneficial thing. Or you could just follow along as I work through the example. So this one says, suppose that labor is the only input used by a perfectly competitive firm. The firm's production function is as follows. It says days of labor. So think about this as kind of almost like number of workers, where one worker could work a full day, or that one worker could work 7 days, or you could have 7 workers work 1 day. But think of it almost like your quantity of labor. The next thing that you can look at is units of output. And so if you look at this first one, one worker working 1 day can produce 7 units of output. That same worker working 2 days can produce 13 units of output, so on and so forth as you add on days, or you could say the quantity of labor. So the best way to look at this one is quantity of labor. And this is your units of output. So the problem is going to ask us a few things associated with this simple setup that we have right here. We have our quantity of workers and we have our units of output. This is an older concept that should be relatively simple for us as we look at the marginal product of labor. And then we're going to use that to calculate the value of each marginal product of labor. In other words, the value of each worker that we add. And one of the ways that we described that is we call that the marginal revenue product. And so we'll look at what the marginal revenue product, how that's derived from this marginal product of labor that we have right here. So the first thing that it asks us in A is calculate the marginal product for each additional worker. That's this first one right here. And so we're going to make an additional column for that one, and we're going to call it the marginal product of labor. And marginal product of labor is really just looking at how much does each worker increase our output by. So if we draw in our lines here, we can calculate our marginal product of labor. It's pretty simple. So if I have 0 workers working at all, right, I have no marginal product of labor. If I add in the first worker, how much did my output go up by? It went up by 7. If I add in the second worker, it went from 7 to 13. So that worker created an additional 6 units of output, created an additional 6 units of output, created an additional 6, created an additional 3 units of output, created 1 additional unit of output, and then 0 units of output. So if you notice, my marginal product of labor starts someplace pretty high and then it falls over hiring people or that person working multiple days. So our marginal product of labor line looks something roughly like that. It's just a downward sloping line. So calculate the marginal product for each additional worker. We did that right there. B, it says each unit of output sells for $10. Calculate the value of the marginal product of worker for each value of the marginal product of each worker. This, in our context, we call the MRP, or the marginal revenue product. Sometimes it's called the VMP, or the value of the marginal product. These two things are the same as each other. They're talking about the same concepts right there. So for that one, we're going to add an additional column again. And for that one, we're going to add this column right here, and we're going to call it the value of the marginal product, or we'll call it MRP. So this column is going to be MRP, and we'll continue our lines to calculate the marginal revenue product. So if I can sell each unit of output for $10, I just want to look at how much revenue does each worker generate. And so obviously I don't have any because I didn't produce any for that first one, but how much revenue did this first worker generate? Well, each unit of output, which are the 7 units, can be sold at $10 a piece, which means this person created $70 worth of goods. This person created an additional $60 worth of goods, $60 worth of goods, $60, $30, $10, and no dollars worth of goods. So this one is showing is how much does my revenue change by when I add one more worker. So it's change in revenue when I add an additional worker. And so we did that for B. That's that column right there. Next one, it says compute the demand schedule showing the number of workers hired for all wages from $0 to $100 a day. Okay. The next thing that we need to do is graph the firm's demand curve. So the firm's demand curve is actually going to look very, very, very similar to the MRP curve. In fact, it is equal to the demand curve. The MRP curve is equal to the demand curve. And so the first thing, well, actually C and D, it asks us to basically compute the demand schedule and then graph that demand schedule. So let's first make the schedule and then we'll graph it. And so for a demand schedule for workers, we need wage as a column, and then we need the quantity of labor that we demand at that wage as a column. And so we're going to use the numbers that we have here and the numbers that we have here to graph ours. And we'll try to have it make sense. So let's start with quantity of labor of 7. Right? What's the willingness and ability to pay 7 workers? Well, that is 0. 0 is the willingness and ability to pay those 7 workers. So in order to hire 7 workers, the wages would have to be down at 0. Well, what about 6? If we were to hire 6 workers, what's the most that we'd be willing and able to pay 6 workers? The answer to that is $10. And hopefully you can follow this kind of logic. If it were to be 5, what's the most? What's the highest willingness and ability? The answer to that would be 30. If it were to be 4 workers, highest willingness and ability is 60. 3 workers, it would be 60. 2 workers, it would be 60. And then 1 worker, it would be $70. Right? I'd be willing to pay 1 worker $70 to work. So this becomes our demand schedule for workers. Then the next thing it asks us to do is to basically just plot that, to graph the firm's demand curve for workers. Well, we know that MRP equals the demand curve. Demand is made up of wages and the quantity of labor. And so we're going to show that here. This is wages. This is the quantity of labor. And we can have our wages range from 0 to 70 and everywhere in between. So 10, 20, 30, 40, 50, 60. We'll make that one 70. And then our quantity of labor is going to range from 0 to 7. Sorry, 0 to 7. So 1, 2, 3, 4, 5, 6, 7. Erase that one. Okay, so if we were just to plot these numbers, you can kind of guess what's going to happen to the demand curve. We're going to have a downward sloping demand curve. So 70 for a wage and plot 1 worker. 60, we can plot 2, 3, and 4. So our demand curve is a little weird so far. But then at a wage of what was it, 30, we had our 4th worker. And then at a wage of 10, we had our 6th worker. And a wage of 0, we had our 7th worker. So, and then we kind of are downward sloping like that. So here's our demand for labor for this firm. Most of the time, we just graph it like that. Equals MRP. Last thing that this one asks us to do is just state what happens to this demand curve, if the price of output, the price of the good that they're producing, increases from 10 to 12. So our underlying context was the price of these things were $10, but we're saying the price of the good that they produce goes up. So just based upon your gut, what are you going to say happens to our demand for labor if the price of the good that they're producing goes up? Well, we're going to assume that the demand for labor goes up. At least I'm going to make that assumption. The way that we would actually calculate it, and it doesn't ask us to do all this, but instead of taking each one of these times 10 like we did before to figure out the value of the marginal worker, we would take each one of those times 12. And so 7 times 12 would be 84. 6 times 12 would be 72. 72, 72, 72. 3 times 12 would be 36. And then we would have 12 and then 0 again. So then if we were to do our whole same process over again, we would recalculate everything like we did before. This would be 12, 36, 72, 72, 72, and 84. If we were to plot that, we would note that all of these moved up. This one's up at 84. These are up at 72. This one's up at, what did we say? It was like 36. This one was up at 20-something, and this one's still at 0. But it would move it like that. So it would shift it to the right or shift it up. In other words, our demand for labor is going to increase or shift right. And that's our answer.